Yeah, you remember this thing. Remember this preselector from, I don't know, 2, 3 weeks ago, up here on YouTube. I'll put a link at the bottom, but boy, did I stir up the dust with this thing. I got a bunch of emails, even a couple of the guys at the club said to me, Bob, you got, you got to get into that thing. You're going to be showing the stuff that you built. You got to show people how to build them. So we did cover how to make these nifty little front panels, the decals, all the nice little nomenclature and everything on there. How pretty. You got to live with this thing the rest of your life. So you might as well do it right the first time rather than sit there and look at it every night and say, I should have done this or I should have done that. Do it right. And then every time you look at it, you'll smile and say, can't argue with perfection. Anyhow, this is this silly thing that, and I'm just going to recap real quick. You can go look at the link and see how we did it. It's much more detail. But what people want to know is how we built all these little modules in here. I've got the multi-tap transformer, which acts as a tuner and matches all your antenna feed points from 25 ohms up to 600. Actually goes to 1200, but that's explained there. Input filtering and protection. In here is all of the preselector, the peaking and notching in this can here. Take the top off. This is the preselector circuitry, and the preamp. I'm going to show you that preamp. This is probably one of the best preamps I've ever used or built, and I'll explain why when we get to that. It's just got very high dynamic range. You're not going to get intermod and overload and stuff like that from this thing. And over here, an output splitter or a multi-coupler, and of course having very, very clean power to drive everything. That's important, man. Dealing with microvolts on the front and 120 volts here. So that's 120 million to 1. Did I say that right? Yeah. 120 million to 1 if you've got a microvolt here. So you really want this clean. That's a ratio you don't want to take to Las Vegas with you, believe me. All right, so let's get into the components of this. I'm building another one for someone, I think, and it's going to be even somewhat EMI proof or EMP proof. Not really EMP, but mostly EMI. We could do that if we had to, but I'm not expecting an atomic war anytime soon. So I'll show you that. This has a lot of shielding. If you notice, even on the cover here, it's the inside. We're all copper covered and coated, and but we even went a little bit better on this new one. So hang on and let me get to that one. The parts that we've got in here. Hang on. All right, we're going to start with. We'll start at the beginning. Make it flow nice. We'll start with the transformer. I'm using type 43 cores. This is it here. It's probably, as I recall, I think that's a 3/8 ID. But I wanted the primaries to be. The rule is you want to be at least twice the inductive reactance for the lowest frequency you're going to deal with. So I wind them for about 300 or 400 microhenries for the primary. And what I wanted to mention in this video is I'm going to try to provide opportunities for you to freeze and use your clipping or snipping tool and catch these things. So we're going to start here, And if you freeze the video, you can go in and use your snipping tool and grab this thing. And this is just rough, instead of doing all the math, which will prove out anyhow to be the same thing roughly. We're working in neighborhoods now, not with exact numbers. And the neighborhood is starting here. I went out to 30 megs. I usually work out to 60, but cover the 6 meter band. And I go all the way down to 20 kilohertz, which actually I'm going down to 10 and below. The last one I measured was good down to 7 kilohertz. But anyhow, type 43, I wind it first, somewhere up around 400 microhenries, 325, 350, somewhere around there. And just start dividing the windings down. That's these red lines. These are the band limits, right? From ELF up to wherever you want to be above HF into the VHF area. And as you can see in that other video, probably you can see, I followed the color code here, red, orange, yellow, and so on. And just started tapping around. And with my reactance meter, measuring the reactance of each tap, or the overall, that's the blue windings here, measuring the reactance, so that when we come over here, and I go to say, because I'm going to be in a 50 ohm realm, right? We're going to be in this area of operation, roughly. Remember, not all receivers are 50 ohms. Matter of fact, none of them are really. But if you think your receiver is, if you have a 50 ohm input, you're working from 20 or 30 ohms up to 1 or 200 ohms. So we do the nominal 50 because everybody says 50 ohms is where you should be. That's this line. And then I just lay in the reactances of each tap here. And depending on how much safety factor you want, if you want 100, I use 200 here for this. You can use 100. You're going to be fine. The losses are going to be the difference between, I don't know, a third or a half of a dB up to maybe 1 or 1.5 dB. 1.5 dB loss would be a lot. So don't even worry about it. You go to bed tonight, you close your eyes, and you say, my toroid is perfect. There's your toroid. And I put all the taps in here. So I don't want to belabor this. You do it on your own. You want to go to 1200 ohms is the worst case for your infit or your little whip antenna or something, down to where I went down to 25 ohms down here. Do what you want, but just get a graph and play with it. Let's do it again. You want to all right, grab your snipping tool. There you go. Okay. I also kept some notes because I did test it. You can't build and run. You got to test it. And I have my inductive reactance notes and the design frequencies here. The ratios based on 50 ohms. So, 0.5 is 25 ohms and so on, 8 to 1. Okay, now, if you want a better view of how this is, take a screen grab of that. Are you grabbing? You should be grabbing right now. Okay. And I color coded it, so red is the this is the chart I use for my preselector, but so the reds and the blues, don't pay attention to. These are the bands we're going to be working in. Now bear in mind, these are the designed numbers, the numbers I put on paper. In reality, there is overlap. This right here, this 30 is actually good down below 20, but you can see the overlap. in the bands. Always keep that in mind when you're doing switched pre-selectors, or in a case of something like this where you've got impedance matching. If you look at your receiver or your test equipment while you're testing this with a 50 ohm source signal generator or something, you're going to see that the differences are so minimal, and I don't know how else to say it except we're not transmitting. We're not trying to squeeze every watt we can out to the feed point of the antenna to talk to the guy on the other side of the planet. We're receiving. We're pulling signals out of the air. We're at the mercy of what the antenna is giving us. So we try to handle it the best we can, and that's what preselectors are all about. So, again, if you're testing this on the bench with good test equipment, not just your ears and the S meter, and you're measuring, say, a perfect your dipole's resonant at the frequency you're listening to, and then you flip the switch here, and you go down to, I'm going to try 25 ohms, see if Bob's full of it or not. You're going to see that S meter move hardly at all, or the AC voltmeter, if you have real good test equipment. Very little at all. And if you go to 150 or 300 ohms, because you might want to consider a running ribbon line or ladder line to your G5RV, whatever you got up there, you're not going to see much difference. So that will prove that Bob's telling you the truth. All right, so much that's too long on balance. Hang on, we're going to move on from balance. All right, next stage. In this is a nifty little copper sheet metal box I made. We're going now. If you want to have some fun, look at, go to Wiki or somewhere and look up Echelon and Tempest. Those are some government requirements and standards for radio spying. Yeah, we're going into the dark area now. But read some of that stuff and about what shielding is all about, and EMP protection and leakage and the pickup of unwanted signals, making the receiver very autonomous so that all it sees is the antenna and not local pickup and noise in your house and stuff like that. It's good reading. Echelon and Tempest. Two different programs, vastly different, but very informative. All right. Now we're going into the pre-selector. There's a lot of that stuff here, so I'm not going to belabor it too long using BB112 varactors here back to back because it's in series with... let me go over here to this. I put the inductors on a rotary switch. And let me get the other one here. Here. Here's another one. I got a can for it. We're going to shield that son of a gun too. A 9-volt regulator, because you're going to get the lowest capacitance, probably around 3 picofarads at around 9 volts. So I'm using a 9-volt thing. That means everything in the system can run on 12 to 15 volts, and you don't have to worry about smoking the varactors here. When you do this circuit, and it's very simple, let me do the hand-drawn guy first. And I'm hoping that's clear enough to grab. I don't know, but I'll show you the final version. Here's all the chokes. Here's a cap, very large. You want this to be about 1 mic or half a mic here and here. One, not to reduce the value of the capacitance of these varactors, but also to keep DC in this loop where it belongs, and the bias adjustment thing. So you've got literally 1 or 2 milliamps, if that much. I don't know what it is. 1 meg, And this could be one meg. I didn't have any, so I used 100K. But that's the basic circuit. Here is how we did it with the peak and notch. And I'm just gonna, because the notching one is already in this YouTube thing that I'm going to leave the link at the bottom, that other preselector demo. We're just going to do it with a peaking one now. And really, in reality, if you off-tune a peak, then you have a notch filter. So, I don't know. You decide what you want to do. You want to do both? That information's on that video. If not, just the peak is the peak's the hot one. That's the one you're going to be using. And you see how I did this? It's the same circuit. What we have, same thing, all the coils. Remember, they're decade coils. 110 and 100 mic, 110 and 100 millihenry. Easy to remember. The back-to-back guys with the anodes touching, and the high value are just to keep the current low and to make these things work. And of course the cap here, keep the DC out of the coil, and the cap here keep. Now, why does Bob have transformers? Well, again, in that video you will see this thing. And what I did was I used impedance. I'm going to call them balance. People holler at me. They're RF transformers. Here's the 50 ohm curve. This one out here is 12 ohms, 4 to 1. And here's 9 to 1 at 5.5 ohms. So you see the effect of the impedance in the circuit. And that's why we have them here. Come in at 50 and go down to 5.5. Same thing coming out. Come at 50, 5.5 out, and then 50 ohms back into the system. I have built these without and worked with just this curve. It seems to be fine. I mean, if you're doing some real serious DXing, yeah, babe, you want to be down here on this one. I mean, look at that thing. And there's the scale, so you know. I mean, you could easily take 15, 20, or 30 dB off of the station that's bothering you. So, all right. Again, there's a lot on this pre-selector peaking and notching circuitry at the other that other link below. So I already said too much about that. Stand by. We're going to move on. Okay, now we can get into the preamp. I've used mimics. I've used ICs. Video ICs work very well. If you want, you play with a 1252. 1252 is it's a darn good IC for it. You get a lot of gain out of it. It's not too noisy. Trouble is, it won't handle a lot of overload, and you're going to get an air mod at some point, especially if you're an AM guy. I've used mimic chips that aren't. They're kind of delicate, and you could lose them with a nearby lightning strike. What else? I don't know. We've used all kinds of things, but FETs, again, kind of dull. Anyhow, here's some regular bipolars, 3904s. You can get quieter versions of this. Very simple circuit. I'm going to let you screen grab that son of a gun. This type of circuit, oh boy, we're going to have trouble. I'm having trouble focusing for you guys. I hope you can get that. I do it in pieces. Yeah, you guys, I'm going to get some bad emails, I know. I don't know. Freeze this somewhere that looks kind of good to you. Well, anyhow, that's it. What I did with this thing is because it's a 15 dB amp. If you short out R1, you're going to get another 5 dB. If you short out R4, you're going to get another 5 dB. So you could be a 25 dB amp if you want. I'm using this as a gain control, 500 ohm pot, linear, use linear, and input drive level, because if you're in a very, very strong signal area, if there's a flamethrower nearby or something, you're going to overload, so it's good to use this. It acts as an attenuator. Or you can come in direct, as I indicate here. We stabilize it with a 100 ohm load. Well, okay, so here's all the biasing. Now we end up coming off of this emitter at pretty low impedance. Keep the coupling caps big. You're not going to hurt anything, and it's going to get you down into the low frequencies without attenuation. 0.47 or even 1 mic. Good quality poly or ceramic caps. The output control, which I'm calling gain because, that's what it is, I guess. Instead of grounding this pot, I put a 4.7K in there, and the reason is that when I go to 0 on the pot, this preamp is still producing gain, but it's been knocked down by this leg replacing ground here enough that whatever signal is here at the input is here at the output. So if you turn the pot to 0, you've got unity gain instead of nothing. Normally, if you turned, for instance, this pot to ground, you'd have dead air. The same here. If this was ground and you turn this pot to ground, you'd have dead air. Well, I picked it up off of ground I biased it up is really what I did. And so at 0, it's unity. If you don't want this, just ground it here, and it'll go to 0. And that's kind of explained right there in those notes. Okay? All right. Enough of the preamp. It is a simple, clean, very durable. I've never had one blow up yet. I've lost some mimics. I've lost some FETs. I've lost video chips. This little bugger, here's what it looks like finished. Very simple. Okay. And put it in a little shielded box too if you want. All right, hang on. All right, finally, I I contacted Charles Olson. Charles is KB9KZY. KB9KZY. And he sells equipment through, or little kits through Jackson Harbor Press. And Jackson Harbor has this nice little thing, or I should say Charles does. It's a 10 meg up converter. There's other videos here on that too, and we're using just a 10 meg crystal. He also gives you a 4 meg, but I like 10 because it keeps all the numbers straight. And a little 602, I think it is, I think they're SA602. Mixer chip, and some filtering, and a little trimming. I got this thing dead on, by the way, with this little trimmer. I got this thing dead on at 10 megs. And what that does is allow you to go down below the broadcast band, and if you want to listen to, I don't know, say you want to listen to 50 kilohertz down there, you set your receiver to 10 megs plus 50 kilohertz, which would be 10.050. And believe me, most receivers are not that good down in LF and VLF, even some of the good shortwave stuff. So if you convert up into the middle of their operating range, like around 10 megs, you'd be surprised at how good your receiver will be. And there's no guarantees there, but that sure is the case with a lot of the stuff I have here. Here's the circuit from Charles. I would have built this myself, but doggone it, for a few bucks, you get the board, all the parts, and quality parts, and why fool around with Why fool around with making your own board? I would make some changes. I would cut the land on the board here. This is the input filter that chops off everything above the. It's low pass. Everything above the below the broadcast band. I'm sorry. So that you're clean from 0, kilohertz up to 500 kilohertz, and then you keep all the inner mod and stuff out of the mixer. And we'll get to that. And then just the buffer output. Here's the crystal setup and the power supply that's built in on the board. Now, all right. So again, what I do is I would cut this land and I would change this cap to a 0.5 or a 1. Again, for the same reasons you want to get down to the LF and VLF bands. That will give you essentially this block diagram where you have the 500K filter and the 10 meg up converter with switches. So now you can come in and elect to either use the filter or bypass it. Then you come all the way up here and you have the option of using the up converter or bypassing it, which means you can use the filter when you're not doing up conversion, or you can do the up conversion without using the filter. That is going to be part of the preselector. Here's the sheet that Chuck has. Charles, I don't know if he likes being called Chuck. This is his schematic. But what I wanted to show you, here's another version of my switching. Maybe that's a little... I gotta get a good camera, huh? But you could see what happens there. You could bypass everything, one or the other, or both, or none, or whatever you want to do. And this is important. The filtering. They're going to find if you're doing LFing, you want the broadcast band to be gone. This filter works good. The red are the numbers he gives you for, I think it's a 3 or 350 kilohertz cutoff. I pushed this one out to 5 kilohertz, so these are the new numbers you would use. 9 turns instead of 6 here. The actual measurements, you should get a reactance meter and make sure you get these right. The 3 caps, that's an 022, 027, 022. And these are the red is the older values. But that's all explained on his website. You go there, you can download the instructions before you buy the thing and read it and get familiar with it. Believe me, for a few bucks, I typically buy these 3 or 4 at a time from him. So he's a good guy, and he's providing a very nice service for us. All right. So, yeah, so, Bob. Okay, you're getting better. Not that good, but better. There is the modules. There are the modules for the next preselector. This is about everything you're going to need to let me get philosophical for a minute here. You got a receiver. You think it's a pretty good one. You got an antenna. You're doing the best you can. Maybe you got a few out there in the yard. That's it. You connect it to, and off you go. Well, now, you could have hamburger or you could have steak. Do you want to modify the signal coming in and condition it a little bit? Maybe instead of having steak, because it's kind of hard to turn hamburger into steak, but you could put stuff on it. And you can make it taste better. I like raw onions and fresh tomatoes and cucumbers, but that's me. And this is how you could do it. You're processing how you're feeding the receiver. The receiver's diet is what you're going to be hearing in your ears. And if you dump raw signal in there, well, you know what to expect. If it gets to be tough listening to certain signals, weak signal, digital stuff, I don't know. Maybe you like chasing AM like I do late at night. Uh, a little bit of help is going to be a big difference, and it's going to put a smile on your face. Here's a guy we didn't, let's put this in a little shielded box. We didn't cover. And I'll do that real quick, and I'll get the heck out of here. It's an input filtering thing. I get some light on it, because I don't know if that's better or not. It's a good idea to have this anyhow, always. Always and anyhow. The typical requisite back-to-back diodes. Up and down. I've got 40K in here as a bleeder. Keeps static electric buildup on the antenna. Yellow's input. Keeps that going to ground. Can't really see it because it's made out of glass, but that's an NE2. A poly and a ceramic cap. These are both 0.5s. Poly and ceramic in parallel. Why? I don't know. Belt and suspenders, but it makes me happy. And blue is the output. Very simple. Alright, I went long, and I'm probably going to have more questions than I would have if I didn't even do this silly video. But I did have a thank you guys for all your nice words and all the emails and everything that you have sent me in the last couple of weeks after the assembly of the after the demo video I made of that monster. All right, that's it. It's cold down here. It was 14 degrees when I got up this morning. The wind's blowing and the air is very humid, and I didn't like it at all. So listen, everybody, stay safe. Watch out for the CV19s, and as always, we love you all. Stay happy. Keep the nice notes coming. Friend me and thumbs up me and put in some nice comments. All right. If not, I don't know. I don't know what to tell you. See you all. Have a good day. It's Bob, N1KPR, www.bobsamerica.com. If you get a chance, go look at it. Bye-bye.